Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's show, I've got something that I know I quite often say this, but genuinely very, very, very interesting. I had a first conversation with this guest a couple of weeks ago, and I it's not that often where I come away from a conversation talking about battery technology thinking, bloody hell, I didn't realise any of that. But I had a great conversation with Nick Kitchin from Cumulus Energy Storage a couple of weeks ago, and very quickly thought, you know what, I've got to get Nick on the podcast. So I twisted his arm, and he's very kindly agreed to come on the show today and talk more about what they are doing. So welcome to the show, Nick.
Thanks so much indeed, Ryan. Nice to be with you. Thank you.
So could we just start, as has become customary, just with an introduction to you? So if you could just let everyone know your background and how you got into this.
Okay, well, if I thought I was going to be where I am at the moment when I first started, I'd been absolutely amazed. But anyway, I started out as effectively a chartered mechanical engineer with an engineering degree from Southampton. I then joined Shell, so I had a pretty classic blue chip background, which was great. And Shell, the plant I was on at Carrington on the west side of Manchester, big chemical site, making lots of plastic, which won't go down very well at the moment with lots of listeners on your call. But nonetheless, it was a really good start for me. And we went through a big culture change program and structural change program in the mid-'80s. And then I went to London Business School for 2 years to do my MBA there. That's where I met Darren, who's now our COO. We'll talk about him a bit later. And then on from that to various packaging companies, general manager background, polyurethane foam. And then, again, a culture change program, wrote a book, and then effectively helped about 250 small and medium-sized enterprises to help get their strategy right. And so lots of strategic consultancy. And I ended up in 2012 or thereabouts, I was analysing the offshore wind power industry, trying to work out whether we could do something significant in that. And I was and this is really where the Cumulus Energy Storage story starts. I was on a conference on the Humber, and I was listening to the politicians, and they were talking about 7,000 wind turbines and 50 billion by 2020, and the same amount of steel as the car industry. And I was thinking, gosh, these are big numbers. How do I find out what we could actually end up doing? Because I really didn't have a clue at that point in time. But I was lucky enough to go on something called the Learning Journey across to California. Yeah. And at the end of that week, well, one particular conversation I remember at one of the universities we went to, this particular professor said, if you really want to do something significant, what you really should do is you should bring in a disruptive technology and intersect that with a wave of opportunity. And I immediately thought that's exactly what we're actually trying to do here. So it was with that I then went on and had my initial chats with Darren, who introduced me to Mike, who's now our CTO. And that's where we started talking about batteries and energy storage. So that's the start of our program. So it's really fascinating background there. And the book is still in print, I believe? The book may well still be in print, but I'm sure it's not many copies have sold, so it's a long time ago. So yeah, don't bother looking for it. It's still in date. It's still very appropriate. It's about leadership and it's about culture change. Yeah, and it's about how to make those sorts of things happen. But as I say, that was a long time ago. So I enjoyed writing that. Thank you. Ah, very good. So solid technical background there, but really. To get into something completely different in terms of renewable energy sector and the grid storage in particular must have been a huge leap for you. Well, when I first decided to have a closer look at this, I thought I'm going to have to get immersed in it. So where better to go than Copenhagen? The European Wind Energy Association had a conference on for a week, so I had a chance to talk to a really, really wide range of people at that conference. And I inevitably got the slight sort of raised eyebrow when I said, I don't really know what I want to do yet, but I know we want to do something significant. Yep. Where are the innovation opportunities? And fortunately, one of the ladies from the European Wind Energy Association took me under her wing, very nice of her, and she introduced me to all sorts of different people. And by the end of that week, I actually had quite a long list of potential opportunities. And then it was about distilling that down after my conversation with Darren over in California a few weeks later, so that we could then identify and home in on what we should end up doing. We identified 3 big projects. Yeah. But as I say, the one that was really interesting for everybody was the energy storage. And
what's interesting for me on that is you took. It's very different to a lot of other kind of innovation stories where I think the classic in people's mind is the kind of mad professor has this amazing invention in the garden shed and then sets about trying to commercialize it. But you were actually you're doing something that a lot of corporates really struggle to do. You were sort of thinking in a very deep and strategic way about this sector and how to move in on an opportunity in the space, but in a very sort of structured and deliberate manner. It's a really interesting way to move into it.
Well, I wouldn't be doing what I'm doing now, or we wouldn't be doing what we're doing now had I not been to London Business School and done my MBA.
Yeah.
And all the strategic thinking and the analysis and, of course, numerous case studies and things. But when you start applying that kind of learning, plus all the people I've been mixing with for the previous 10 years or so at SME level, then applying that knowledge and trying to do it strategically to try and come up with something that was going to be significant. I didn't want this is a lifestyle business.
Yeah.
I didn't necessarily have to have something I knew a lot about already. As long as I had the right team around me who could put those skills and those strengths into the team, then that was fine. It was about doing something significant for the planet.
Yeah.
It was about doing something that was very, very scalable. And something where it was what I would call a blue ocean as opposed to a red ocean.
Yep.
So Randy Maughan's book,
Yep.
Red Ocean, Blue Ocean, etc. And that's precisely where Mike's concept, Mike Howitz, our CTO, his concept for the battery came from. And that's literally where the whole thing started. So,
okay.
It's just quite strategic.
So perfect segue into telling us what is it that Cumulus do?
So Cumulus Energy Storage, as everybody says, it's fine when renewables have the wind is blowing and the sun is shining, that the electricity is being generated, but that may not be at the time that it's actually needed.
Yeah.
And this is the big issue for renewables, as everybody is aware. So we spotted, as I say, back in 2014 or thereabouts, that's when we really got going. We spotted the fact that large-scale, low-cost, long-duration energy storage was something that was missing from the mix. Mm-hmm. And I have to say, I've already talked about raised eyebrows at the European Wind Energy Association conference, but when I started talking to people about energy storage, they were sort of saying, "What's that? Why are you interested in that?" Now, obviously, the conversations today are totally different, but that was where it was up to at that particular point in time. So we had to work out what we wanted and needed to do. So the basic principle and premise that we founded the company on is I challenged Darren to challenge Mike to say, okay, if we want to make batteries, which ones should we make and why?
Yep.
And Mike's response was, we should start with large-scale, tried and tested chemistries from typically either the water industry or the mining industry. And we ended up choosing the mining industry. And we should take those large-scale processes, we should actually make them slightly smaller to make them suitable for energy storage. And what this will do is it'll reduce our risk, it'll reduce the development time, and it'll take an awful lot of cost out of our development program. So rather than trying to do what lithium's been doing for a long period of time in terms of making something that's relatively small and making it much, much bigger, we've actually been going in completely the opposite direction. So with the associated benefits of doing that.
Right.
So we selected the mining industry.
I can imagine people listening to this are now going, what? what could they possibly be doing from the mining industry, which is where I was at when I was talking to you. It blew me away where you kind of took this this concept from. So what is it you've brought in from the mining side?
Okay, so if you want to extract metals from an ore, you have to first, you go through a two-stage process. You leach the metals out of the ore to start with, and then you go through a process called electrowinning. And electrowinning is, very large plants, hundreds of megawatts, and those plants last for a long period of time. And essentially, you have electrodes in the electrolyte, and you're continuously coating those electrodes with copper or zinc or other non-ferrous metals. You physically scrape the copper and the zinc off the electrodes, put the electrodes back in, and you build it up again, and you just keep repeating that process. Yep. So this is it's a sort of one-way process, if you like. But the interesting thing that Mike did was he went a stage further than that. He said, okay, Volta, some 200 years ago, he had a battery that consisted of discs of copper and zinc with some cardboard and some brine in between. Again, a single-use battery used in the telegraph industry for many, many years. And he said, well, I wonder if we could make that rechargeable. And he thought about it and said, well, if we put a membrane in between the copper and the zinc discs in Volta's battery, we could prevent the copper and the zinc going to the opposite electrode and therefore potentially end up with, and this is exactly where we have ended up, effectively two electrowinning plants back to back, but separated by a membrane. So what happens is every time you charge the battery, copper goes into solution, zinc electrowinds onto the zinc electrode. Every time you discharge, zinc goes into solution, copper electrowinds onto the copper electrode. So every time we do a complete cycle, we're actually refreshing the electrodes. So we don't see this capacity curve, this capacity fade that people keep talking about with lithium and lead and various other battery technologies. It's the wear component is the membrane. Yep. So I think we've been really, really lucky, but we've managed to patent all this. So we're now the only company in the world, luckily, that can make and sell rechargeable copper zinc batteries, which is quite amazing since people have had 200 years to do this.
Yeah, well, I mean, I've been in the battery space for quite a while, and it's not something that I'd come across before. So it is, it's fantastic innovation. And, I mentioned before we started on this call, I love the fact that you're in the UK and you're in the north as well. So
we're in Yorkshire.
Yeah.
Best place. With the northeast being a possible exception, given the person I'm talking to at the moment. Yorkshire, fantastic place. So lots of innovative businesses based at the Advanced Manufacturing Park. It's in Rotherham, but it's actually close to Sheffield. Yep. Very close links with the University of Sheffield for fairly obvious reasons as a consequence of that. It is a really, really good place to be. And then our R&D facilities is over in the US, in California, which is where Darren and Mike are. So we've actually got our foot in two, I would describe as key countries involved in energy storage. And so I think we've got the best of both worlds, even if there is a time difference between the two. So, yeah, it's been good. It is good.
Presumably the membrane that you are using is a special kind of membrane that allows electrons to migrate across it in much a sort of similar way to the membranes in a lithium battery would work.
It's not the same as lithium. Mm-hmm. It is a widely used membrane. Mm-hmm. I can't tell you too much about it, unfortunately, because of constraints in terms of patent applications. But essentially, what it does is it stops the copper and the zinc ions going through, and therefore contaminating the opposite electrode. But it's designed to be a low resistance electrode. It's designed to help us get a very high round trip efficiency from our system. And what it means is that we have an assembly process that is very closely aligned to the automotive industry, which I suspect is another reason for being of interest to your listeners, hopefully. Yeah. So we have two pressed metal pans that form the structural part of the electrodes. We coat the insides of those with the copper and the zinc, and those two pressed pans then effectively come together. They form each side of the membrane, and then in the two voids that we create, as a consequence of that, we put in the liquid electrolyte. Right. So this is very much an aqueous battery, but it is not a flow battery.
Right.
There are no pumps, no no parasitic losses in terms of having to move liquid around the system, etc. So again, it's designed to be very simple, very low cost, but also very green.
Right.
I should talk about that in a minute as well. So,
and these are you're really aiming at big proper big batteries with these, yeah.
Yeah, these are seriously big batteries. A small battery would be in a 45-foot container, for example.
Yeah.
Standard shipping, 45-foot standard shipping container.
And you're saying that it's not like in a 45-foot container in a small box in the corner. It is the 45-foot container. So these are big giants.
These are designed for large-scale applications, grid scale. So just to give you a feel for some numbers, so a small battery for us would be 250 kilowatts, stroke 1 megawatt hour system. Yeah. That would be in a 45-foot container, up to potentially 100 megawatts, 400 megawatt hour system, which I think would make us one of the largest batteries in Europe. Yeah. That's the kind of scale, and that would obviously be inside a building. So that's the scale. But that's the kind of scale that the industry, or industries, if you like, need, because that's the kind of scale that people are operating at, certainly in terms of transmission, distribution. Yeah. And batteries are getting bigger. Wind farms are getting bigger. The cost of wind energy is getting lower. Cost of solar is getting lower. Solar farms are getting bigger. Everything's getting bigger. So, as I say, the missing link is having this longer duration storage. So, it's a good place to be.
Apart from the kind of obvious, there's been a huge amount of development in batteries in the automotive space, typically on higher energy densities, making, more energy, more power into smaller and smaller and lighter and cheaper, because its costs have fallen drastically. Typically lithium packs, and lithium's kind of become the chemistry of choice for now, although there's some other interesting stuff coming through on that. But you're, I guess, deploying those automotive cells in grid scale applications, like a 4 megawatt hour or 400 megawatt hour made out of 18650s is an almost unimaginable. Like you couldn't.
You really wouldn't do that. No, that's quite right.
Yeah, you might have a cheap cell, but you're going to have a very, very, very complex and expensive battery and EDS by the time you finish. So you've really kind of taken a different approach, where lots of people are looking at, well, we can use automotive type cells, and that we get the advantage of this, the scale from the automotive side there and the cost. You've said, no, we're going to make something very specific for grid energy storage. It's not going to be any good for automotive, but we don't care. We're not interested in stuff with wheels on. We wanted to stay still and tackle that market head on with something specifically designed for that purpose.
The way our battery cells are manufactured is very closely aligned with the automotive industry, in terms of the materials that we're using, in terms of the application, in terms of the cradle to cradle, that whole life of it, and our ability to extend that life out to more like 30 years. So it's more of an infrastructure asset than a battery in that sense. Yeah. And it fits the same kind of lifetime as various other components in the electricity network. So we've done this very specifically and deliberately, with a view to ending up with this low cost energy storage system that's very, very scalable, but also environmentally friendly. So we needed to think about what sort of scale are we likely to end up at, or potentially end up at, and would we end up with some sort of environmental issue in terms of material availability if we did this? Yeah. So you've probably seen various forecasts recently to do with Europe's battery capacity, for example, up in the sort of circa 400 or thereabouts gigawatt hours per year capacity by, I think, 2024. So if you want to think about that, then we really do need to be talking about hundreds of gigawatt hours rather than a few megawatt hours, etc. Yeah. But at 100 gigawatt hours, even if we just kept on going at 100 gigawatt hours a year, then it will still take about, well, certainly in excess of 1,000 years to use up the world's resources of zinc and copper. Yeah. And if you look at it as a percentage of the total production capacity, the annual production capacity of copper and zinc at the moment, it's well under 2%. So it's a lot lower than both cobalt and lithium right now, as a percentage of annual production. So I really don't see that as a constraint. And obviously it's available from all over the world, no concentration of the elements in a specific country or countries.
And the very big battery systems, I mean, it's part of the argument that people have developed for grid scale hydrogen. You see some big projects coming online. There was some big announcements a couple of weeks ago from Germany in terms of what they were doing. The EU's announced some big hydrogen projects. And essentially the gist of those is it's not practical to store energy with electrochemistry at a sufficient scale for big grid support for renewables. So their plan is we will create green hydrogen from renewables. We can store the hydrogen, and then we can either turn it back into electricity through a fuel cell or some other means, but at massive scale, at these sort of like hundreds of megawatt hour type scale. And that's understood technology in terms of big gas storage is easy to do. People know how to do it. But your system really, it strikes me, would be coming in and be competing against that kind of technology with a much more efficient round trip efficiency than you could ever deliver with a hydrogen system. Is that the kind of thing you're aiming for, or is it?
Yeah, I wouldn't actually class hydrogen as a competitor to us.
Okay.
There are some alternative, liquid electrolyte battery systems. The sort of 4, 6, 8 hours kind of duration delivery. They're much more closely aligned with us in terms of being direct competitors. But I'm sure you will have heard this said before. At the end of the day, there will be a large range of technologies required in terms of all different forms of energy storage, sub-second, right the way through to seasonal storage, in order to deliver the total needs and turn us into this genuine low carbon economy, where we can rely on the sun, apart from anything else, and the wind to fuel us in the main.
Yeah.
So, as I said, I don't really see hydrogen as a competitor. It's quite expensive, apart from anything else.
You don't see it as a competitor in terms of because that just fills a different space in the market, or because
it's a different space in the market. It's doing a completely different job. Yes.
Yeah. I wasn't sure if you're just trying to say we're just so much better than hydrogen. It's
no. We've
different space.
Look, I can sell this, but I can sell this all day.
Yeah.
But at the end of the day, there are disadvantages to what we do as well as advantages, and it's like all the other technologies out there. It's about selecting the right kinds of applications that play to the particular technology's strengths.
Yeah.
That's what this is about. So hydrogen in one space, flow batteries in another space, lithium's in another space. So again, lithium and copper zinc, very much complementary sets of characteristics, complementary offerings. And we see lithium really being used mainly in the EV market. Mm-hmm. And if you look at some of Bloomberg's forecasts, 8,000, 9,000 gigawatt hours cumulative usage of lithium, for example, then 80-90% of that is in EVs.
Yeah.
Well, you're not going to want to when you've got all that battery resource in the electric vehicle market itself. It's being driven around and it's being put into cars for obvious reasons. And you've had numerous people on your show before talking about that. Whereas when you then start talking about the EV recharge or battery applications, you're going to want a low-cost, environmentally friendly system that can facilitate that. And that's where we sit. And that's why I really don't see lithium as there are some examples out there now of, 4-hour, even 5-hour, 6-hour duration lithium storage. But is it a sensible way to move forwards?
Yeah.
No, I think there are much better ways of doing it, personally.
It's interesting because it's a big part of, obviously not necessarily the biggest in terms of scale, but the biggest certainly in terms of noise in the market is Tesla, and a big kind of pillar of their business moving forward. I mean, they went as far as changing the name of the company, so that they're sort of an energy business now that also happens to make cars, and they've sort of looked quite hard for lots of opportunities for their lithium batteries, and grid storage is a sector that they're really sort of pushing on,
Yep, I agree with that.
And would you see the systems that Tesla are kind of putting into the market as being competing with you, or being different to the kind of systems that you would provide?
Well, one thing I've got to be really thankful to Elon Musk for is he has managed to get the whole solar PV plus EVs plus energy storage, get that message out so that I don't have to explain what energy storage is anymore. Every time I just put those two words together, everybody goes, "Oh yes, I understand. That's interesting."
Yeah.
And which specific bit are you doing? So he because of his background and brand and all the rest of it, is able to tweet various things to certain people in certain parts of the world and get reactions. And he's very able to move very quickly, and he's got a lot of financial muscle behind him to facilitate that. But fundamentally, he's also playing in the energy storage market. He also has to make sure that his technology and installations and all the rest of it have the appropriate returns. And he will be playing to lithium's strengths. And he's changing the chemistry as well, the batteries, etc., to optimize, reduce cobalt, and lots of things that he's doing, as indeed are lots of other people. But yeah, you're right. He's probably the one that most people will know about most readily. But actually, where they as well, as you know, where most of their batteries seem to come from Panasonic. Yeah. So he's not actually manufacturing. Well, he might be in Germany shortly, but to my knowledge at the moment, he's not really manufacturing that many batteries. He might be doing battery packs, but not the batteries themselves.
Then they're putting together packs with cells. In Panasonic's been their partner for a long time. It's almost a sort of coexistence with them and other suppliers as well now in China, and potentially bringing some in-house for themselves. Yep. So I guess from that, your system, would be competing against the large batteries that Tesla are putting out for grid storage. But what's your differentiator then? How can you sort of take on that? How can you take on that? Okay, so I might be stating the obvious here, but the thing that drives the overall cost of a system is the cost of its materials, its active materials. The balance of plants, so all the bidirectional inverters and those sorts of things, packaging, etc., is pretty much, it doesn't really matter which chemistry you're using for that. That's pretty similar, regardless of the chemistry. So the thing that's key to differentiate, and the key that's there to drive the cost down, is actually the cost of the active materials. And because we're using copper and zinc, which are low cost, certainly compared to some of the materials that are used in lithium batteries, low cost, they're all commodity products, and therefore, as we scale up, and our intention, by the way, or at least our aim, is to help re-employ some of the people from the automotive industry and re-employ them in our energy storage assembly plants. And those assembly plants, they could be not necessarily quite as large as some of the automotive ones, but certainly, heading in that general direction. Yeah. So we're talking about some significant employment, but we're also talking about significant scale, and therefore we're talking about significant cost reductions in terms of supply chain, unit cost manufacturing, and it's a really, really simple process to put our system together. And we also don't need sophisticated battery management systems. We don't need lots and lots of layers of sophistication that we can strip out simply because it's a low energy density system. It's a system that's got lots of water in it, so thermally it's very stable. It's very heavy. We don't have to manage every single cell. Just simple. Two key principles: low cost and keep it simple. And those are the two things. Wow. Yeah, it's kind of the winner, isn't it? For in grid storage, some of the things that are important characteristics for automotive just don't matter. The energy density isn't significant. Sure, it gets to a point where it does become an issue in terms of having the physical land space available for a battery, but you'd have to be pretty big batteries other than that. But then, really, if you're operating this as an energy asset, it just comes down to commercials, doesn't it, at the end of the day, in terms of what's your cost to produce that, what's its life cycle, what's then the total cost of ownership, and how does that compare to a lithium pack?
Yep. So two things. Can I just talk about the applications for a second?
Yeah, go for it. Yeah.
So and just to give you a feel for where would we use our system? So offshore wind, from the UK perspective, is one of the key strategic aims. Obviously, huge growth, but obviously the offshore wind has to come onshore at some point. And if we can put one of our systems next to the onshore substation, we could then operate at transmission level and have a DC-DC connection and have a really, really high round trip efficiency as a consequence of that, and facilitate that offshore wind to get to where it needs to get to at the right time as a consequence. Another application would be enabling more wind-generated electricity in Scotland to then go through the transmission system down towards the southeast of England, where most of the demand is. That's quite constrained. Interconnector markets from England or Wales, between Wales and Ireland and Wales and Scotland, and vice versa. Those interconnector markets, for example, and they could also apply across to continental Europe as well. Yep. And then if you really want to go slightly further afield, then diesel engine genset replacement markets, so electrification of the mining industry across Australia, 600 million people in in Africa with no electricity. So we could, for example, do microgrids with our energy storage as part of that, or diesel engine genset again replacement in India to help 300 million people there with, again, either intermittent or no electricity currently. So the range of applications is absolutely massive. So anyway, that's that bit of it. And I think you asked me another question before that, which I've quite forgotten.
So I was drilling down in terms of the commercial aspects, and basically it's cost. But the essentially, the total cost of ownership model for this sounds like it's got some advantages over a lithium battery system.
So there are two key aspects to cost. One is obviously the original CapEx cost, which everyone's very familiar with. And then there's also the levelized cost of storage, which is something that Levelized have been able to facilitate over the last, I think, 5, 6, 7 years now. And that levelized cost of storage is really the lifetime cost of the system in a net present value calculation. I won't bore you with all the details. But essentially, if you compare the different technologies for similar size applications, you can then do, assuming that the revenue streams are the same, then obviously the lower the levelized cost of storage, the better the returns should be for that particular project. That's the logic. And this particular levelized cost of storage does include things like end of life costs.
Right.
So lithium would need to pay for that end of life cost for recyclability, for example, whereas we will get paid. But all those costs, charging costs, CapEx costs, and all the rest of maintenance costs, they're all included in that levelized cost of storage calculation. So it's a really good way of actually comparing for the same application or the same project, which chemistry or which application, which technology should I be using for this particular application. And so we've used their model, and we've looked at how our levelized cost of storage compares with lithium, and then how that compares with flow batteries. So if you take the lowest cost for lithium, and then you take our copper zinc cost, when we get up to scale, we will actually have a lower levelized cost of storage than lithium. So that again is a key message to put into the marketplace. But that's where we expect to be, lower than lithium.
Right. So better life cycle costs overall than the lithium packs. And you mentioned the flow batteries, which there's a few of those sort of coming into the market. I'm guessing, clearly you wouldn't be doing it if you didn't think it was commercially competitive, but you're competitive as well with the sort of flow batteries and that kind of thing.
Well, the flow, I'm not here to knock the competition, but the flow batteries, so vanadium redox does use very expensive components. You can't get away from that, to the point where they're currently leasing the vanadium part of the battery system. It's just as a means of taking that out of part of the CapEx cost.
Right.
And then the zinc bromine, that has got some fairly significant environmental aspects that need to be thought about quite carefully. So the vanadium redox and zinc bromine will have niche applications, but I honestly can't see how either of those can really be very, very large scale, the mainstream application for the grid scale markets. So yes, as I mentioned before, we need a wide range of different technologies with different applications. But if you want, and just the same with lithium's become the incumbent for EV market, for example, then Cumulus and our rechargeable copper zinc, we see this as where it should end up going with regard to us becoming the incumbent for the stationary energy storage market. Okay. That's what we're trying to achieve.
So, finally, my next question was literally about to be, where do you see this going for Cumulus? Are you going to grow and be a vast manufacturing operation? Are you more of an energy services provider? Are you going to license this technology down the line? What does the future hold for Cumulus on that front?
We originally thought about setting up and selling energy storage systems, and I think initially that's precisely what we will be doing. But I think that further downstream, we will, because we're not really adding any value through buying in and then applying a bidirectional inverter. It's not really adding value. Where we add value is through the chemistry and our own IP, our own knowledge, if you like. That's where we're really adding value. So I think we'll end up selling batteries as opposed to battery systems,
right,
or energy storage systems. And in terms of what would we like to see? What would we like to do? Well, we'd really love to be able to set up a gigafactory. And I know this is becoming all the rage, and this is a slightly overused term already. But a gigafactory in the UK making stationary storage that's environmentally friendly, that helps renewables. We just need a little bit of government support to facilitate our production facility, and then the likes of British Volt and their 30 gigawatt hour and their 1 billion float that was mentioned over the weekend.
Yeah.
Well, why not?
Yeah.
I mean, literally, why not?
Yeah.
So you have to think about that kind of scale to be competitive in the overall marketplace. So we are thinking big. We want to do something very significant. And then in terms of the bigger vision, rather than us trying to do things in each individual continent, we'd like to partner with large strategic corporates, right, so that we have one, for example, in Australia, another one in India, another one in South America and such like, where they facilitate gigafactory equivalents. And we end up with a number of different gigafactories where we can share our experience and our knowledge and our patents and all the rest of it, and get those plants licensed. So we end up with licensing royalty revenues and license fees for each megawatt hour that's produced. So we don't necessarily need and want to manufacture globally, but certainly the opportunities are global. So let's go there and do that.
And do you see those sort of bigger players in the traditional? I mean, start again. In the automotive market, the traditional incumbents have really hurt a lot. So in the energy market, you've got the GEs and Alstoms and Siemens, etc., who have in the past been building these large thermal power plants and the transmission and distribution hardware. Do you see any of those guys taking an interest in the energy storage market, being good people?
Well, I mean, again, Siemens and AES, etc., Fluence, as it's now called, have a pretty high profile, to be honest with you, in this marketplace already. GE has got various energy storage technologies that it's currently working with. So yes, I do see these large strategic corporates. Many of them, as the world changes from high carbon and all the power station, all the rotating equipment and all the rest of it, as that changes significantly, which it is doing very quickly, then the companies involved in those markets have now got to find alternative sources of income. So at some point further down the road, then yes. Now, whether it's going to be an automotive business or whether it's going to be an energy company that ends up owning large amounts of energy storage, and I don't mean for specific projects, but it just takes on that whole technology space. I'm not quite sure which way it's going to end up, but it wouldn't surprise me at all if an energy company eventually ended up becoming someone that works alongside an automotive company, but doing the stationary bit as distinct from the EV markets. Yeah. So that's a distinct possibility. But I think the the energy companies, and I used to work for one. They've got a way to go, to be fair.
Right.
But the change is happening. The realization is out there now. It's obvious from the strategic changes and thoughts and what you keep reading every day. The drivers are out there. COVID has given us an insight, a glimpse into the future. So, it's becoming more and more obvious that little lot needs to change. So
it is, because you mentioned the electric vehicle piece there, and the grid storage. One of the big objections people often have to mass deployment of electric vehicles is the charging infrastructure. Big problem with the charging infrastructure is the grid infrastructure in places, but particularly for high demand, like a truck depot or a bus depot. These are huge challenges that need to be overcome, and grid sort of buffering batteries is one of the ways of doing that. But the cost at the minute is very, very high to drop a system like that in, and it basically, I've heard people say, it effectively doubles the cost of deployment of something like electric bus or truck fleet to have to do a grid storage system in your depot. And you are talking, in the order of megawatt hours that you need if you're charging hundreds of trucks up. It's a big system that you need to do that. So these are huge. There's some huge opportunities in amongst just even that space.
Well, it depends. It depends how you do it, and getting rid of the need to upgrade the overall infrastructure helps take a large chunk of the cost out of the system.
So can you tell me then? So it's been really interesting to sort of discuss the market and the applications in the future. I guess bringing it back to the present day, what's Cumulus doing today? Like, where are you at as a business? What stage are you at? How proven is all of this? What's your kind of your current status?
Okay, so we've been through several rounds of funding. We've had a significant number of UK government grants. We are literally raising some money at the moment in order to be able to set up our own production facility, making megawatt hour scale production on an annualized basis.
Right.
And then the next step after that would be to then set up a full production facility, which would be circa 500 megawatt hours up to a gigawatt hour per year production capacity. So the trick, of course, as you sort of alluded to, I think earlier on, is getting that next tranche of money in is the key one. Yeah. That's the bit that unlocks the production. That then means we can have demonstrator systems that people can come and look at. That then stimulates further investment in projects, and et cetera, et cetera. So right now we've done some feasibility studies for an energy storage project in Ireland, which shows some very healthy double-digit IRRs, and another one in the southeast of England, which is co-located with a biomass plant. So these projects are up in the sort of 50, 60, 70 it's 50, 60, 70 megawatt hour scale,
right?
Just to give you a feel for it.
Right, big.
But that's the kind of project that we're being asked to look at the moment.
Right. So you basically, you need to get your investment sorted out for that. Would you call it pilot production, or is it just low?
Yes, pilot production for the initial, circa 30 to 40 megawatt hours of production per year. Yeah. For the pilot production, and then after that, move on up to the 500 megawatt hours, etc. for annualized production. And then the gigafactory. Here we go.
The systems that you've made so far, have they been kind of made lab scale?
They're very much production intent. So right. The system, the battery packs we got at the moment are full scale. They're production intent. They've been made by the components have been made by the same people we get to make our containerized systems. Yeah. So we are very, very close to getting that commercialization in place.
And how do you manage? Because one of the things with lithium batteries is, I've been in a number of cell plants, and it's always quite entertaining. You get togged up in the big white suit and put your masks on and walk through the big air blower, and kind of then you're inside this sort of ultra clean environment inside a normal lithium. Okay. So that, because I was thinking there, how have you? Because if you want to pilot produce lithium cells, it's really hard. I mean, I talked to Kevin Brundish from Amity Power a while ago, and that's their business at the moment. They've got this clean facility. They do pilot production for people on lithium cells because it's such a huge capex to get that manufacturing facility up and running. But you don't need that.
We don't need that. A lot of our processes are pretty industrial. Right. The biggest electricity consumption is for our what we call the forming process, where we put the copper and the zinc on the insides of the two electrodes. Right. But other than that, it's an assembly process, and that's really where aligning that whole skill set with, if you think about a car, pressed metal pans. So you talk about door panels, for example, small door panels, so pressed metal parts for the automotive industry. Yeah. You then talk about an assembly process. Again, that's exactly what goes on in the automotive industry. Yeah. And automating that whole assembly process and having those energy storage devices on automatic guided vehicles, for example, just going around the same sort of facilities you'd find in an automotive plant, using the same kind of robotics, again helps drive that total cost down. So that's the kind of thing that we've got in mind to help this move forward. It is very closely aligned with that, but we don't need the clean room conditions. We don't need the expense of that. Our capex cost for our assembly plant, our gigafactory in inverted commas, would be a lot lower than that for lithium gigafactories, for example. So again, from that capex point of view, there's an initial much lower capital requirement for that production facility, which then rolls through, obviously, in terms of overhead reduction, which then rolls through to lower total cost of system as well. So the whole thing, as I said before, is designed to keep it simple and keep it low cost. And
so just to give people an idea, so you're talking about basically a steel plate that is then coated with the zinc or the copper. So you've got a kind of electroplating process there.
Yeah. So just to give you a feel for scale. So instead of talking about instead of talking about the small cylindrical cells that you typically get for pouches you get for the lithium. Yeah. This is a large scale. So it's about 1 meter long. It's about 200 millimeters tall, and it's 30 to 40 millimeters thick when you put the two pans together with that membrane clamped in the middle. So that's an individual cell. Wow. So about 5,000 of those, as opposed to 10 or 20 times that, for a container for a megawatt hour, that's what we're talking about. And then you just have to, you put each of those cells in series, and they're literally touching back to back, and copper, zinc, copper, zinc, copper, zinc. You slide those into racks along the long length of so you've got your 45-foot container. The long length of that, inside that you have racking, and you slide your cells in lengthways into the various parts of the racking. And then, as I say, they all touch, so they're in series. So then you have strings of cells that you're managing, not individual cells you're managing. So again, some little layer of complexity that's taken out of the system. Right. It's really, really, really designed to be low cost, but really, really simple.
And how, a lot of the BMS, the management electronics on a lithium cell is because they don't like being overcharged, they don't like being undercharged, so you can't fully discharge them, which creates issues with transport and such like. How do your cells perform in that sort of way? Can you?
So we don't have to manage each individual cell for a start. So we have, as I mentioned before, all the cells are in series, in strings. So all that's happening with our cells is that we've got literally very gentle movement of metal from an electrode into solution, and then from solution onto another metal and back again. So we don't have the same kind of power density, we don't have the same kind of amount of energy, we don't have the same kind of fire risk, for example, that certain chemistries have got. We just don't have that. We've got a very large thermal mass of water in each of our containers. That's the electrolyte. So we might get a couple of degrees centigrade difference as we go through a complete charge discharge cycle, etc. And even if we start even doing ancillary services and relatively large number of cycles, it's just it's a low energy dense system, and it's just treated like a black box.
You don't have to worry about dendrite growth or any of those sorts of things.
No, the volt and hydrogen coming off and all the rest of it. The voltage isn't high enough.
Right. Okay.
So
very simple, stable.
Yeah. I mean, we'll have to don't get me wrong. We'll have to put fire extinguishers around, but it won't be for the chemistry.
Yeah, electrical arc risk, I guess, probably more than anything.
It won't be for the chemistry.
Yeah. You always use some of the electrolyte to put the fire out.
Maybe not. Yeah. We'd like to reuse that and recycle it.
Yeah. Okay. So just to wrap up then, what are you kind of most looking forward to that you've got coming up over the next year?
Well, just talking about the government and some of the policies of the Ofgem and all the rest of it, we've had some really good wins in this last month or so from Ofgem. The double charging bit, for example, and getting that removed as of next year. So if we can get more policy decisions and more policy changes to help facilitate larger scale storage, so another one being 49.9 megawatt scale storage, that limit being removed as well. So they're all helping to increase the scale of the batteries. They're all helping to reduce the unit cost of the systems.
Yeah.
That helps drive down the unit cost from the consumer point of view, as well as apart from anything else. So really, what are we looking to answer your question directly? In addition to those policy changes, getting our finance in place for the pilot line, moving on from that to also then set up the full production, then building the relationships with strategic partners globally on a continental basis and intercontinental basis. That's the sort of thing that we were looking forward to be able to move forward on, and just want to do something significantly positive for the world, but also for UK PLC.
Yeah, that's brilliant. I can totally understand that sentiment. Very much what motivates me and has been behind the Avid journey as well. So fantastic. It's great to hear. So thank you, Nick. Thanks so much for taking the time out to do that today. Sorry, the listeners won't hear it, but I will mention it because you had to endure it. So we'll edit out the interruptions. We were interrupted a couple of times to sort of work from home, and it was all my fault, basically. So Nick coped with that like an absolute pro, though, and has done a great job. So thank you very much, Nick.
Well, thank you very much indeed for asking me on the program, Ryan. Really enjoyed it, and hopefully it will be interesting for a number of your listeners as well. And if people want to get in touch, I think you probably tell them where the website is, and we'll take it from there. But thanks so much indeed.
I will. It's a good point, actually. We'll put some show notes in. So if you go down to the show notes, we'll put some links in to Nick, so you can find him on LinkedIn and their corporate website, so you can find where that is. And anything else that's come up in the conversation that I can link out to, I'll put links down in the show notes for that. So if you're interested, go and check out the show notes.
Thank you very much indeed. Nice to talk to you.
Well, that's all we've got time for today. I hope you found that interesting and got some value out of it. Rechargeable copper zinc. So not something I had come across before. I'll probably get howled at. Loads of people know about it already, but I personally hadn't seen that before. I think it's fascinating. Nick's story and journey is absolutely fascinating, and how he came into be doing what he's doing now. I think Cumulus are really onto something there in terms of the potential for this technology. They're not trying to compete in the automotive space, but really targeting this straight at the grid storage market and having a product that's suitable and designed specifically for that space. I think is a very very sound business to be involved in. Check out the show notes if you want some more links through to Nick. Don't forget to leave us a rating, hit like and subscribe. We've got some really, really good podcasts coming in the not too distant future. So don't forget to subscribe to our channel, however you happen to listen to us. And I really look forward to speaking to you again soon.